Hi everyone. Today I'm gonna come to section 8.1, and we're gonna talk about functions and their representations. Okay, so let's have some definitions. Firstly, functions. What is a function? Function is a set of order pair, say x, y, where each x value correspond to exactly one y value. So you can see over here uh, in uh, in the left hand side I have an x will have a y value, exactly one y value. Okay, so like 2 here also have exactly uh, a value y, and 3 here a value of y. And a function take a valid input x and compute exactly one output y. And if forming the order pair is as x comma y. You see that? And so then this is this is a function. You can see that, right? What about the one in the right hand side over here? You can see the first one, number 1 over here, have one value y. That's good. What about number 2 here? One value of x have two value of y. See that? Two value of y. That is not satisfied. Yeah, so this is not a function. Not a function. Okay, so I have function notation is as y equal f of x. So they write like this. And we read y equal f of x. See that? F of x. Okay. One more definition that we also need to learn in here is about domain and range of a function. The domain D is a set of all valid input or x values. And the range, so is the domain D, is set of valid input or x value. Okay, so let me separate this. I'm gonna separate this. This one. Domain, range. Okay. So the range R is a set of all output or the y value. Okay. Let's we have an example. Okay, example 1. I have say f of x equal to the set with some point s 1, 2, 2, 3, and 3, 3. Okay. So domain D in here is all valid value of x. So I have what is the valid value of x? This let me use other color. This one, this one, this one. So they are the valid value of x in this function. So then domain should be 1, 2, and 3. What was the range? Range error. gonna be let me use the yellow one. Range gonna be the value, the set of all output with all the y value. So here's 2, 3, 3, or just 2 and 3, right? Because we have two number 3, so then they just have only 2 and 3. Okay. All right. So that is for the range and the domain. What about, move down here, another example. What about f of x equal to x squared? What's the domain of that? Right, we want to find the domain and we want to find the range. So if you take a look at the graph of x squared, we try to graph it, it's going to be look like this. Okay, it is a parabola y equal to x squared, right? So you might talk about domain. I will consider about the valid value of x, or the input, right? So in this case, I will take a look at the value of x. So you can consider for any value of x on the x-axis over here. Say here at this point, do I have a value of x on the graph of y equal x squared? So you're gonna coordinate it, and you're gonna say, oh, the graph will go to this point, and there is a point here. And even this, like if you come to the negative infinity, you can still get a point that's on the graph that have x value is a negative infinity later. So there's no gap, no hole, nothing that breaking the graph, right? And if I come to 0 here, also there's a value of x on the graph when x equals 0. That's a valid one, right? And keep moving to the positive side, right? You can also see in here there's a value of x. So you can see that from the left to the right, from the negative infinity to positive infinity, right? There's all real number, all value of x is satisfied for this case. So the domain in this is from negative infinity to positive infinity, or we call all real number. Okay, so all real numbers. Okay. What about the range? Range. The range is a valid value of the either set of all output or the y value. If you talk about the y value, then you wanna take a look at the y-axis over here. Let me use other color. Say blue one. Okay. This one. If I choose a value here for y, a negative value, do I have any? I have any point on the graph that have y is negative? No, you see that? The y value is, the minimum y value was at here, at 0, okay, at the origin. And then you keep moving up and see all the other from 0 to positive infinity will have a value of y on the graph. See that? So I would say the range is going to be x. If I use interval notation, you're going to be from 0 inclusive 0 to positive infinity. Okay. Or if I use the inequalities notation, I'm going to have x greater than or equal to 0. Oh, no, sorry, y. Let me say y, because this is a range. Okay. All right. So that is the answer for the domain and range. All right, let's see. Okay. So let me get down. Oops. All right. Now I'm gonna talk about recognizing representation of function. Okay. So a function can be represented by verbally, symbolically, numerically, and graphically as below. Okay. So for verbally, it is precise word description of what is compute. Okay, or maybe oral or written, and must be stated precisely. For symbolic, it is mathematical formula, and it efficient and concise way of representing a functions. For example, fx equal to 2x minus 3. Okay, so this is going to be a function. All right. And another one is numerically representation, which is a list of specific input and their output. And it may be in the form of a table for an explicit set of order pairs. And lastly, graphical or diagrammatic, it shows input and output visually, and it has no word, formulas, or table, and and many types of graph. It has many types of graphs and diagram possible. So let me have an example for you first, right? Say example for let me write it, verbal representation. Okay, I want to have an example for verbal representation in my word, right? Okay, so I'm gonna say to convert, oops, to convert X jar to Y feet, we multiply X by 3, right? So function f compute the number feet in XR with a verbal presentation of f is multiply the input X in jar by 3 to obtain the output Y in feet. So this is the verbal presentation for a function. Okay, so it's just by word. There's no formula at all in here. Okay, usually this just for you to say a function. Okay, so now I'm gonna talk about symbolic representation. Symbolic representation. So this is formula. Okay. So I can present the function above by f of x equal to 3 times x. So in here, maybe I'm gonna write something like let the computation performed by f to convert x year to y feet is expressed by y equal to 3x, right? So a formula representation, a formula. So a formula for f is fx equal to 3x. Okay, so this is a symbolic represent. Okay. And okay. And now we move to numerical one, right? Let's have numerical presentation. Representation. Missing presentation. All right. For the numerical representation, I actually is like a table of values, right? So I will have like a table we call T table. It's like a T here, okay? And the left hand side is usually is input, which is X value. In here it was jar, right? The number of jars. And the right hand side is the Y value, which is output, is feet. So if I have one jar, then Y gonna be equal to 3 times 1 equal to 3 feet. Similarly, if I have 2 jars, then I have 3 times 2 and be 6 feet. And keep going with 3, and then I have 3 and 3 is 9, right? Okay. And then we have one more as 4. So 4 times 3 is going to be 12, right? You can keep going with some more value, but I just gonna stop here with only 4 input and output. So this is called like a partial numerical representation of F. Because many valid input so that input such as x equal to I say 5 and y or x equal to 6, keep going, right? I'm not showing it. Okay. So remember that, note that. If this is a function, so for a function, input x and not listed more than once in a table. What does that mean? Let me move up here. If I have a table like this, here's X, here's Y, I mean that's right. I have 1 and Y equal 2, have another 1, I have 3 here, and 2 I have 4, and 3 I have 5, something like that. You can see I have 2 number 1, which is of input, give me 2 value of output. So this is not a function. Okay, not a function. Okay, what else do I miss? We have numerical, we have symbolic, we have verbal, and now we come to the graphical. Okay, all right, move down here. Graphical representation. Which is a graph. Okay, you may gonna ask me, hey, how can I graph? How can I graph a function, right? This is a very important thing that's that you need to know for the next level of math. So this one visually associate an X input with a Y output. So we have the order pair. Such as 1, 3, and then what else? I have 2 and 6, and then what else? 3 and 9, and then what else? I have 4 and 12, right? So according to this one, I have 1 and 3 here, 2 and 6 here, 3 and 9 here, and 4 and 12 here, right? Okay. So so from this order pair, I can graph, or I can plot. I can plot on the XY. Okay, so let me draw the XYZ, sorry, XY coordinate. So how can I have a line? 1 second. Okay, so draw a line. Use this one. This one, right? I have this one, and then oops. Oops. This it, and then another one. And then I have this one. Okay, move it up a little bit. Okay, so now I'll draw. All right, so I have, here is y and here's x. In order to plot, you should plot all the other pair, all other pairs. And then connect, then connect a line with no break between all the point. Okay, so let's plot. Firstly, I have 1 and 3, right? So 1, 3, 1 is value x, so I put 1, 2, 3, 4, 5. I have the maximum of x is 4, right? So I up to 5. I have maximum value of y is 12. So I need to have 12 up to here. Okay. And I'm gonna say have that gonna be 6. The scale should be could be different. It doesn't have to be exactly the same, right? So I call here it is 6. And then middle here should be 9. And middle here should be 3. All right. So I have 1, 2, 3, 4. Okay. So and I said before, it doesn't have to be the same scale for between x and y, but if you can do that, then that's nicer. Yeah. How about this? For this time I'm gonna do same scale for you guys to see. So I have here is 3, here is 6, here is 9, and here is 12, something like that. Okay. So I have the first one is 1. 1 was maybe here. 1 and 3, right? So 1 and 3. So 1 point is here. I call it 1, 3. What else? I have 2 and 6. Here is 2. 2 value is for x, right? So you plot 2 with 6. Here is 6. Here's 2. Okay, so watch out. How can you grab it? Make a vertical line from 2 in the x value, and the horizontal line from y value at 6. It intersects at the point that you are looking for. Okay, so this is called 2, 6. Let's use other color and see for the next one. I have 3 and 9. So start with the value at x equals 3. Draw a vertical line through that 3, and then 9 is value of y. So draw a value, a horizontal line, go through that. Number 9, and in the horizontal line, intersect with the vertical line as the point, which is 3, 9. Okay. All right. So lastly, I'm gonna use the blue one. Number 4 for X. So I draw a vertical line, go through 4, and let's go up to 12. And 12, from 12, I draw a horizontal line, and there intersect at 4, 12. Okay, so now what you do is you just gonna draw the line, go through all these points, and that should be the line we are looking for. How can I make it bigger? Let me see. Make it bigger. Okay, so we have finished the graphical representation for the line y equal to 3x, or f of x equal to 3x. Okay. All right. So let me make some connection. So make connection. Okay. So in here, I know there's Lx equal to 3x, right? So if you want to see like f of, say, f of 2, right? F of 2, what is that equal to? Right. So what you do is you will use x equal to 2, and look at the x equal to 2 here, right? You see the point on the graph and looking for the y value of that point. That is 6. So that is value of f of 2, which is equal to 6. Okay. Similar with, say, f of I don't know, 3. You will have what? 3 is 9, right? Okay. Or maybe I have f of 4. Then that's going to be equal to 12. Okay. Okay, so let me move down here. One more thing that I want you guys to know about definition of independent, say, called independent variable. Which is the input variable. Usually it is x of a function. Okay. And the dependent variable is the output variable, usually is y of a function. For example, you have say f of x equal to 2x, something like that. Then what else? Then x is independent variable. If I have say v of r equal to pi r squared, then r is independent variable. If I have y equal to f of x, then I'm gonna say y is dependent variable, because y depend on x, right? Okay. Or t equal to f of r, then t is dependent variable. Okay. And we're gonna learn about vertical line test. Vertical line test. What is a vertical line test? Vertical line test is if every vertical line intersect a graph at no more than 1 point. The graph represents a function. Okay, so for example, okay, if I have a graph over here, y equal to x squared, look at that, right? And I'm wonder, is this a function? Right? I'm gonna use vertical line test and try to have some vertical line to check if the vertical line intersect, or the vertical line intersect the graph only one point, right? I see that wherever I draw a line, a vertical line, I just see only one intersection point with the graph. Then we can say this is a function because every vertical line intersect vertical line intersect the graph at one point. All right. What about in this case? I have another one. There's B. There's A here. All right. So I have another one like this. Okay. Look like a parabola, right? Is that going to be a function? I'm going to use vertical line test. And I see that. Oh, the line cross at 2 points. The vertical line intersect the graph at 2 points. So the vertical line intersect the graph at 2 points. So that is not satisfying the requirement of the vertical line test. So then I'm gonna say this is not a function. Okay. All right. That's pretty much we need to know. Just gonna have some more example for you. Example. What is that example now? I just want to say 4. Evaluate function fx at the given value of x. Okay, so let's say if I have f of x equal to 2x minus 1 and x equal to negative 1 comma 0. So what I do is I'm gonna have 2 cases in here, right? So solution. I have at x equal to negative 1. Now, f x change to be f of negative 1. Now input become negative 1, right? See, this input change to become negative 1. And that equal to 2 times with x change to be negative 1 minus 1. Okay? And that's going to give me 2 times negative 1 is negative 2 minus 1. That equal to negative 3. Okay. What about at x equal to 0? I will have f of, now input change to become 0, right? F of 0. Going to be equal to 2 times with, okay, x, but now change to be 0. And then minus 1. So 2 and 0 is 0, minus 1 is -1. Okay? So that is a way to do the evaluate fx at the given value of x. Okay. So what about example 5? I'm gonna write function f as a set of order pairs. And then we give the domain and range of f. So I have, say, f of 1 equal to 3, f of 2 equal to -4, f of 3 equal to 0. So I can have order pair for the first one here. It's going to be 1, 3, right? Input is 1, output is 3. Okay, the second one going to give me 2, -4. And the third one will give me 3, 0. So this should be the set of order pairs. So F1 is this one. Fx1 is that, right? So domain will be what? Domain will be the set of all input, which is 1, 2, and 3. Remember that? 1, 2, and 3. Right? And the range will be all the value of y. So 3, -4, and 0. So far, so good. Let me move that. And there's an example. What's that? 6. If I ask you about sketch a graph of f, right? Let's say fx equal to -x plus 3. How can you sketch this one? Okay. So you need to have, firstly, you need to have a t-table. So first step, make a t-table. Table for value of x and y. Okay, so have x and then what and y here, or y equal to f of x. So I have, let's say x0, f of x going to be -0 plus 3 equal to 3, and then 1, I have negative of 1 plus 3, which equals 2. And then 2, I have negative of 2 plus 3, gonna give me 1. All right. So from here, I will have some other pair such as 0, 3, 1, 2, and 2, 1. And then I'm gonna draw it by plot each other pair here. So the maximum value of x is 2. So I have 1, 2, 3. So here's 2, here's 0, here's 1. The maximum value of y in here is 3. So 1, 2, 3 to up here. Okay. So I'm gonna plot all the value of all the pairs. So 0 and 3 first. This one. What else? I have 1 and 2. 1 and 2. So that another one. And then 2 and 1. So here 2 and then 1. So here's another one. So then we can just draw a line go through this 3 point, and that should be it. Where is that? Which? Okay. That should be a function fx. Similarly, you can do the other one like that, okay? So I think I'm gonna start this section here. If you have any question, you can come to see me and to get help, okay? And I'm gonna see you next time.